Nuclear fusion is an incredible new technology which has the potential to revolutionize the world. It involves taking the same power that the sun uses and bringing it down here on Earth. Atoms in nature have bonds that keep them very close together. However, they are still not close enough to fuse because the electrons which orbit the atoms keep them at a distance that is great enough so that they will not fuse. So the most common way of achieving fusion here on Earth is through plasma fusion. This involves taking two very light atoms, the lightest being hydrogen, and heating them up to huge temperatures, 6 times the surface of the sun. This results in a plasma being formed around the atoms and then stripping away their outer electrons. Now, these high energy particles, which have gained energy from the heat, will now collide with each other, fusing together, forming helium, and now making energy in the process. Bottle of water. If we manage to fuse all of the hydrogen atoms into helium atoms in this water, it would give us enough energy to power cities for weeks. However, if it was that easy, where is all the fusion energy? Unfortunately, it isn't that simple, and today we've hit a major barrier in fusion technology: efficiency. So currently, the energy produced by the fusion reactions is not enough. We put more energy into heating up the atoms and molecules than we are getting out of the reactions. So our reactors simply aren't good enough. Through the use of incredible particles called muons, it is possible to achieve stable fusion at 20 degrees Celsius, down from the 100 million we needed for plasma fusion. Now the muon is a subatomic particle. Closely related to the electron, they're kind of like cousins. But the muon is, well, it's the bigger cousin. When I say bigger, I mean heavier. It's much, much heavier. 207 times heavier than its electron counterpart. But they both have a negative charge. This means that the muon can take place of the electron in the orbit of an atom. Now, when this happens, a fascinating thing occurs. These orbits that the electrons would usually follow, they shrink down to a much smaller size. If we look at the original orbits and compare them to the new ones, we find that the distance is now much smaller. And this smaller distance, when these atoms form bonds, it's close enough for these atoms to fuse on their own without needing any heat or energy to bring them closer together. So by substituting muons in place of the electrons in atoms, we'd be able to achieve stable and safe fusion at room temperature. So it'd be incredible. We could have fusion powering our homes, our cities, our buses, and everything, all safely, cleanly, and greener for the future.